All right, this is section 14.1. We're going to start talking about stoichiometry. First of all, just to let you know what stoichiometry is, it is basically when we are doing calculations based on our reactants, based on our products, so the balanced chemical equation. We're doing some calculations using the equation. That's the idea of what we're doing in stoichiometry. Comes from the Greek word, however you pronounce that, stoichion, which means element, and metron, which means measure. So we're talking about measuring, the elements. All right, so let's take a look at this equation. And we've got a balanced chemical equation, N2, nitrogen gas, plus 3, hydrogen, H2 gas yields 2 NH3 gas, 2 ammonia. And there are a number of things that we can look at and think about when we're looking at this particular equation. We could say that we know that based on the coefficients, based on those, so this is going to be a 1 here. Based on the coefficients, we know that one molecule of nitrogen would react with 3 molecules of hydrogen. And that would produce 2 molecules of NH3. So that's one thing that we can look at on this equation, and we can determine that from that. Because there's a ratio between molecules and moles, we can do the same thing in terms of moles, which is very useful for us. We could say 1 mole of nitrogen plus 3 moles of hydrogen give us 2 moles of ammonia. So we got the same thing. Okay. Now, the one thing we can't do, we couldn't say that 1 gram of nitrogen, gives you, plus 3 grams of hydrogen gives you 2 grams of nitrogen. That doesn't work. But we could look at the molar masses and kind of figure it out. So if we had a mole of nitrogen gas, nitrogen is 14, so 28 grams of nitrogen, that's a mole. If we looked up hydrogen, H2 is 2, and there's 3 of them, so it'd be 6 grams of hydrogen. So 28 grams of nitrogen, 6 grams of hydrogen would give us 2 times NH3, which is 14 plus 3, or 17. So 2 times 17 is 34 grams. And the important thing is that when we look at this, 28 plus 6 equals 34. That's the law of conservation of mass, so that's a good thing. So while we can't directly, the coefficients don't tell us directly what our grams are, we can use moles and figure out our grams based on the moles. There is one other thing that we can do here. If we're talking about, in this particular case, they're all gases, the ratio for gases would also be the same as all of these other ones. So I could say 1 liter of nitrogen plus 3 liters of hydrogen gives me 2 liters of NH3. So it's kind of an unusual reaction if you think about it. If I started with 1 liter of gas here, 1 liter of nitrogen, 3 liters of hydrogen, so 4 liters of gas, I add that, I put those together, and I get a reaction, and I actually only get 2 liters of gas at the end. And this, of course, is all at STP. That's what I would get from that. So it actually gets to be less in this particular reaction. So the key to take out of here is that I can talk specifically about moles and molecules. I can calculate my grams from that. I can talk about liters. Those are things that are useful that I can figure out just from this balanced equation. All right, let's just take a look at a couple other ones of these and just think about this. Okay, so from these equations, you should be able to look at and say, oh, 2 molecules of C2H6 plus 7 molecules of O2 gives me 4 molecules of CO2, 6 molecules of H2O, or 2 moles plus 7 moles plus 4 yields 4 moles plus 6 moles. You should be able to look at those equations and do that. So stop this just a second and think through that next equation there. So hopefully you thought, hey, 1 mole or molecule, whichever one you wanted to think of KBrO3 plus 6 moles of Ki gave you 7 moles of KBr, 3 moles of iodine, and 3 moles of water. Okay, so these ratios, eventually we're going to learn some things about these, and these ratios will be very important in the next section when we are reacting. Notice that these aren't like equal on both sides. On this side I have 7 moles, and on this side I have 13 moles. There is no law of conservation of moles. That doesn't matter. However, if we did figure out grams, we would find once again that the grams are the same, but moles not necessarily. So moles, molecules, liters, those will not be the same. Molecules would not be, formula units would not be, if we did count atoms, if we counted atoms for both sides, they would actually be the same on both sides for atoms. So that's kind of the main thing. If you can look at that and just understand what those ratios mean and be able to write out, hey, 1 mole, or liters, or molecules for any of those things. And eventually what we're going to do is we're going to talk about ratios. In other words, if I started with 2 moles of C2H6, I'm going to end up with 6 moles of H2O. And I'm going to use that ratio when I'm doing some calculations later on. So that's kind of the important thing out of this section. All right. So there you have it.